got the machine cleaned up. We got our table nice and clean, and then it's going to mount to the back of this Kurt vise right here. So I've already got these two holes blowed out really well. You can see there's a shelf right here, and the sidewinder actually sets right on top of that. Everything should be nice and clean, so we'll just go ahead and set her in here and start getting her bolted in. Just like that. They've got a dowel pin right here which helps line up on those holes nice and easy. Just get it squared up to the back of the jaw, pushed over against that pin, and it sits there. And then a couple of the socket head bolts go through and bolts it in from the back side there. And those other holes line up to an 8-inch vise, so you can use it for that too. Okay, that's bolted in there, and this is lining up nicely on those holes there, the support foot. So we'll need to get a stud or a bolt and hold that down there, and that should be good. And one thing that I overlooked, I'm just not used to using this vise, but it has a built-in stop here that you can set too. I forgot about that whenever I was figuring the work stop here. So we may just end up using this work stop right here instead of having the shaper gauge mounted on it. Pull one of our little rubber caps out of here, maybe this one. And I got a couple bolts up here. Let's see if one of these will work. I think just for good measure, we'll go ahead and put two. We'll go ahead and put 2 bolts in there since they're lining up good. Found a couple bolts that should work. All right, it's been a while since I used it, and I did have it trammed in. You got this area right here that's ground on the body of the vise. I'm going to get an indicator set up, and we'll go ahead and indicate this and see if it's trammed. But on the end of it, you have these 4 bolts right here that you loosen up because you do have to get it adjusted according to whether you're using a 6-inch or an 8-inch milling vise. This was set to a 6-inch, but we'll go ahead and check it because it may have moved there between setups. I think for this, we're just going to use drill chuck, and I've got a Noga and the Starrett 811 test indicator. I'm just going to control it with our hand pendant. All right, that's a 0 there. Getting it adjusted in Y. Get it readjusted. Let's get a Z established there. That looks good. And I'll get you guys a better video so y'all can see this. Let me just get it set up and moving. Let's go ahead and give it a sweep. Half a thou. Not quite a half a thousandths. So, you know, that's good enough where it's at right there. That 0, it didn't move, so it drops about a half a thou right about there, and then it kind of comes back up closer to the 0. 2 to 3 tenths. Yeah, there's nothing wrong with that. I mean, especially for the job that we're doing here. We don't need ultra precision to face and engrave the end of a handle there, so I think we're just going to leave it right where it's at. So that kind of makes me happy because All we did, we had it trammed previously and adjusted here. All we did was just set it back in here, bolt it into the vise, bolt it down here, and look, we're within a half a thousandths being trammed. So good to go. I promised you a better video of that indicator, so here it is. You can see right about in the center, it drops down about 4/10. I'll just call it a half a thou. And then we come up to about, you know, what, 2 or 3/10 under 0. Depends on where you land at there. All right, we're going to move on to getting our height set here. So let's, I'm going to loosen this stop up so I can move it like that. But we've already got our planer gauge set, so I'm going to use that to kind of get it established. This being a, I don't know, it looks like just a piece of coil flat bar. A little bit harder to get perfectly flat there, so we'll see if we can get her. I'm going to use one of our steel samples here because I'm going to prove it on a couple of these guys before we move on to our brass. So we'll set this down in here like that. And I got to find the vise handle. That should be good right there. Move that off. I can feel it touching the bottom of our part. I don't want it sitting underneath the very center of any of the handles, because some of them that, remember we were having that issue with the live center kind of pushing in on that, on the cut center, and so you have a little bit of a burr there. So if you just touch the face of it, that should be good enough right there. Something about like that. Let's see. Yeah, if I roll it to the center, I can kind of feel that burr. So right about there feels pretty good. That should be pretty good right there. Yep, I can feel that touching right there. And since that's still set, we can still use this to set our Z, because then, I mean, we don't have to be up underneath the vise there. We can move this out, and I got one of my blocks here, but this is what I was talking about. We can easily set some blocks here if we want to, stack another one up here. These are precision ground 1, 2, 3 blocks, and then have it up here so that we're not having to come up next to our vise. But I mean, honestly, we could slide it out here and do it just the same. So I guess it just depends on how you want to set it up. But anyway, that's kind of what I'm looking at on establishing our Z there. I think what we'll do is go ahead and stack a couple blocks up here. That way I don't have to worry about this big spindle coming down, getting close to this. So we've got our surface that is going to be 0. We're just going to slide this forward a little bit. There's a little chip there. All right, and I'm going to use 2 of my Steerit 706 blocks. These things are precision ground. I mean, they're so close to what a gauge block. I'm going to show you how flat these things are. Make sure there's no dust on them. And just put them together. Ring them together just like you would a gauge block. Look at that. They are stuck together. That's how flat they are. Pretty cool, huh? All right, and then we'll just set this guy right here on our shaper gauge. And then we'll touch the top of this, that being exactly or right near at it 6 inches. Once we touch this, we'll just input a negative 6 inches down to our 0 point. Right about there. Looks good. All right, we've got it set to single surface Z, G54, a -6 to our Z position. There we have it, Z is set. Just going to kind of eyeball the center of our part there. It's looking pretty close to the center of it, I believe. All right. Just a little bit more. Okay, and I'm going to use a program Z move to get down far enough to be able to probe the round shank. We'll go ahead and get these guys out of here. We don't need them anymore. I already did this just to be sure I was right. You can see our XY is on 0, but for our probe cycle, we're using Boss, 3/4 inch diameter, G54, X and Y position 0, and I chose to go 1/2 inch negative in the Z position there to get down to the shank. But we'll run this again so you can see what it looks like on the probe. I got you guys at the computer. I'm going to give you a little quick rundown of what the machine is going to look like in the mill. So here's the brass handle from the lathe, and we just continued on after we did the lathe work here and made another op. And by the way, I actually made 2 second ops, one with brass, one with steel, and all I did was just change my tools so that I could prove it out on the steel using a different end mill than I was going to use for the brass. So we'll just show you the brass. I'm going to come over here and activate that setup there. And the origin is going to be at the very bottom right there. If we shift around, you can see this is the bottom face there. That's going to be our Z0. All right. And then all of our work is going to be right here at the top. So if we zoom in right there, and it's going to be really simple. We're going to start off with a spiral pattern, a spiral tool path to face it off. That's going to be this guy right here. We'll go ahead and simulate that because it's just one pass. It's going to bring it to the model total length there, just which is 7 5/8 from end to end. So we'll use a 1/2 inch 3-flute end mill there to do the spiral pattern and machine the face off. And the chamfer is already machined on there from the lathe from the previous setup. All right, and then the next one, it's going to grab a engraving tool, and then there you can see what I have done is I've brought in a DFX file of my A-Bomb 79 logo and applied it to this. You know, we put a sketch on here and applied that DFX file right to the top. I had to scale it and position it correctly, and I usually have to go in here. You zoom in, you kind of miss it, but it goes away. I mean, but I have to come in here and kind of clean this up because there's a lot of lines in this thing that is really needs to be taken out for such a small engraving pattern that we're doing on this. And that's just there from the guy that actually designed this logo so long ago, back in 2013, I believe. It's been a long time. But yeah, I have to clean it up a little bit for the engraving. So anyway, we'll activate this, simulated I mean, and we're going to use a 90-degree engraving tool, and it's just going to come down and engrave the logo. I've got it set to 1/1000 deep here, and then I'll adjust that on the machine as I need to on our axial wear, if I need to take it a little deeper or shallow it up, whatever needs to be done. So all right, so there's the engraving. All right, and then and then what I'm going to do last is we'll come in here with well, we got to exit that. I've got another cleanup pass right here, and this is a copy of our first tool path, okay? And if we come in here and I edit it, over here on the passes tab, what I have done is I've clicked stock to leave, and on the axial stock to leave, I've added a positive 4/10. Okay, so that tool will come down here and do the same exact tool path, but it's going to be 4/10 higher. And the reason for that is for the tracing pattern right here is probably going to leave a burr sticking up, and we can just deck that off with another spiral path. So if we simulate that, you'll see it's just going to come down and do the exact same path, but only 4/10 higher. And once it does, you see all the stock is gone. That's why it's all green now. It's just going to clean that face up without actually touching the face, because I want to leave the tool marks, the original tool marks from the first spiral face on there. All right, so it's just going to clean up the burrs. And that's it. That's all it is to it. So those 3 tool paths right there. And then once that's done, these handles will be completed and finished up. So we'll head out to the machine and get started on them. I did some testing off camera so that I could make sure that our program is working good on our first steel piece here. I've got it going. I'm going to show you the program. One change that I made on there besides the tool depth, I had to adjust the depth of my engraving tool on my tool wear offset, but it was raising a burr, and I know this is steel, it may be different on the brass, but I think it'll do it on the brass too. But once it engraved it, it sort of raised the burr up on there, and it made the logo look a little distorted, fatty, I guess, if you will. So I edited the program to bring my end mill back in here and just make one pass across there at the same depth, just to remove the high spots or the burrs off the logo, and that worked out really nice. I think it's set where it needs to be, so we're going to go ahead and reset it, and I'll put another one in here, and we'll cut another steel handle so you can see what I'm talking about. So I know that's hard to see. We'll get you some better shots of that logo right there. But that looks pretty good. It's a little small, but I've got it adjusted as large as I can get it to fit on the end of that handle right there. So anyway, that's working out pretty good. Let's go ahead. I'm going to grab another one of these steel handles, and we'll put it in here. And I'll show you the program complete. Now that I know we're not going to crash, and it looks like it's machining it nicely too. Okay, here we go. Cycle start. One pass just to face it off. Now we're going to swap over to our engraving tool. I'm going to turn on the air just to help blow the chips off of it while we're cutting it. I did make I made a tool wear adjustment on the engraving tool, -0.001, and that seems to be leaving a nice line in there in the logo. And by the way, I'll show you up on the graphics here. We can watch it in real time. Pretty cool. Now we'll grab our end mill again and just make one more pass across that face. Just to remove the burr. That looks good. It's consistent with the first one that we cut here. That looks nice. So I think we've got it. I think we've got her figured out. And I've got a few of these steel handles that I made as just sample runs, you know. So it looks good. But I'm going to go ahead and finish cutting the steel handles just to get all those done. Because these, I don't know what I'm going to do with them. We might put them up on the website if anyone's interested in these. But anyway, I'm going to get through the rest of the steels and then we'll set our brass up and check that out. Okay, I'm happy with that. We've got all of our steels machined. I'm going to go ahead and remove it. We'll put a brass handle in there. And I've got a different program I'm going to draw it for that one just because I'm using a 3-flute end mill instead of that 4-flute. But that's looking good. I like it. I just want to be sure none of that engraving dust is in the jaws here and messing up the finish on our brass handle. All right, let me get that program drawn up and we'll test this one. This will be our first brass one that we cut. Okay, we're ready to run. I'm going to bring this down slow just to make sure that everything is the same. 3-flute 1/2-inch end mill here. Running 8,000 RPM on this instead of the slower speed on the steel. All right, just making sure that I have everything set right. That looks pretty good. And I'm going to send it. That's it. Quick and easy. That face looks nice too. It's got a nice little spiral pattern to it. Bring this down slowly as well. Just want to make sure that my heights are set correctly. Okay, looks good. 100% here. Turn our air on. So we will run the end mill back across it as well, just to clean up the burr off of the logo. That being brass, that cut line actually looks nice and shiny compared to the steel. And of course, that steel handle that we made, that's 1018 cold roll, so it's soft and gummy. It doesn't put out really good finishes like a brass handle will. I'm going to stop it once it's through that engraving just to, I want to feel that and I want to look at it a little bit better. See if we need that face pass. I'm going to halt the program. Stop the spindle. Yeah, you can feel it. It's got that burr on it, but it's hard to kind of see it. Let's go ahead and we'll continue on. I want to see what it's going to look like compared to the steel running the same tool path there. So we will start our spindle and hit resume. Okay, that was it. Let's see how we look. I think it looks pretty good. I just want to make sure it's right before I take it out, because you can't line that back up once you pull it out of there. I think it looks good. I think we're just going to leave it right where it's at. I'm going to see if I can measure the depth of that. We should be able to with our 643 gauge here. Just got to get lined up on a line there. All right, so 1,500 feet. That seems right where we got it programmed with our tool offset. All right, I'm going to go ahead and take that one out. I do have an extra one for me, and let's see how it looks. I don't know if you guys can see that or not. I'm going to get you some better shots of that so you can see it. I'm liking it. Let's carry on. Looking good. Yeah, that looks good. I like it. I think we've got a good combo going there. Well, this makes 12. We're halfway through. We got another 12 or 13 of them total left to machine. So we're just going to keep this going. Everything is working out great. Really liking the finish that it's putting on the face and then the engraving. Everything's just working out well. I'm real happy with the program and the tool marks, the finishes. The vise is working great. Everything's just working great. So yeah, we're just going to keep working our way through. Finishing these last 13. Hopefully some of the video that I've got, I was trying to get some close-up detail video, which is always very challenging inside these machines to get, but I think we got some pretty good video there for you. And I'm just going to work my way through and get the rest of these guys machined. Shouldn't be too long. I'll have to check. I want to say that this program is right at 2.5 minutes, and that's for the facing and the engraving and then decking it off one more time. I think it's right at 2.5 minutes. Turn the air on. But again, I am really happy with the way that's looking. The way the button kind of looks like on the end of the handles. Hopefully the fellas up there at the state parks is going to like it too. And if you guys go out there to Fort Macon State Park and you're looking at the cannons that they have restored, hopefully you'll remember to see if you can find the handles on the elevating screws there. I wanted to give another thanks to Kevin, my buddy up there at mechanicaladvantage.com. I say just about every job that I do, there's usually something here and there that I'm unsure about or I know can be improved and done a better way. And so we'll get on a session for a few minutes and he'll look at the tool paths with me and he'll help me kind of, edit it to make it more efficient. Or if I'm hung up on something and I can't figure out why I can't do this, can't do that, he always jumps in there and looks at it with me and helps me. So that's always been a big help. So if you guys are looking for any help or training for using the Fusion software for CAD and CAM, Kevin's your guy. Give him a check. Go to his website. You can schedule him for 30 minutes at a time. And he's a valuable source of information when it comes to CAD and CAM, especially for Fusion. So that one looks good. I absolutely love, once you start getting the hang of doing CNC work like this, production work, not one part, not two parts, but production parts. It's so nice being able to repeat these things over and over again. Exact same tool path that's going to give you the same finishes, same results every time. Cycle start. Forgot to look at the time again, but I believe it was 2.5 minutes on that. So, all right, 12 more to go, including this one, and this job will be wrapped up. That makes number 25 right there. Job is pretty well finished up. Well, this job is wrapped up. We've got these handles finished, and I'm happy with them. I sure hope Paul and all the other guys up there at the North Carolina State Parks enjoys them just as much. This is, I mean, it's definitely what they asked for, and I think we knocked it out of the park. We got it done. I had a lot of fun using both of my Milltronics machines to get these done. You know, we used our SL8 CNC lathe to do all the turning on it, and then we just finished it up over there on the TRM 3016, and both machines did a fantastic job. I absolutely love learning and having the capacity of the CNC machines to be able to do jobs like this, easily be able to do repetitious jobs like this for customers, and create parts better than what I could have before only using the manual machines. But I love every machine I have, and I love being able to use all of them, but I absolutely love continuing my learning journey on using the CNC machines to get some of this work done. And I was so humbled to be asked to be a part of this project. You know, Paul reached out and asked if this was something that I'd be interested in helping them do, which we have done. So next up, we're going to get them wrapped up, you know, protect them, get them boxed up nice and tight, and get them sent up there. So don't forget, these are going to be going to the Fort Macon State Park, and they're going to some replica cannons that they are building. I believe it was, I threw away my notes from the last video. I think it was 1863. They had a Civil War battle there, and they are building several cannons as replicas to put there at the fort. So I tell you what, me and Abby are both excited for the opportunity to be able to travel up there. You know, we love doing the traveling with the RV, and one of these days we're definitely going to take a trip by there, and hopefully they'll have some of these cannons on display so we'll be able to see the handles. But just to recap real quickly, these are going into elevation screws that Paul himself has machined for the cannons, and each one of those elevation screws gets 4 of these handles in there, and they sit in this orientation like this to be able to turn that elevation screw, and that's what adjusts the pitch of the cannon itself. So just very thankful to be such a interesting part of this project, and I was glad that we were able to provide this service for them up at the North Carolina State Parks. So be sure to go by there and pay them a visit, and check out the cannon restorations, and I'm sure they've got tons of other really cool stuff there at their state parks to enjoy as well. I know we certainly enjoy the state parks whenever we travel. That is ultimately what we always try to stay at, is a state park, no matter if it's in Florida or any other state. That's where we like to go and enjoy. So great public spaces for everyone to get to enjoy, and we look forward to visiting there and seeing the work that they put into these cannons. So I hope you enjoyed the video and the project. Thanks for following along, and I hope you come back for the next project. All right, we will see you then.